Hi, I'm Madhura Dias. Have you ever come across with Stack Overflow exceptions when using recursions in C Sharp? In this video, let's see what should we know when we use recursions in C Sharp. This is the agenda for the video. First, I will show you a simple algorithm written in C Sharp using tail and non-tail recursion. Next, let's compare the space complexity of writing the same algorithm using iteration. Finally, I would like to talk about the tail call optimization. Here I have written an algorithm to calculate the number sum. Number sum is nothing but adding numbers from 1 to n. We can use this formula to calculate the number sum more efficiently, but in this video I am adding numbers one by one to show you the concept. Here I have written the algorithm using tail recursion and non-tail recursion. In tail recursion, recursive call is the last statement of the method. But in the non-tail recursion method, results of the recursive call is added to the number. This is the IL code of the tail recursion method. If you look at here, this is the last statement of the method which is making the recursion call. Then next statement is just a return. But if you look at the non-tail recursion method, after this recursive call, we have another add statement. As you can see here, I have some unit tests. First, I am going to run the unit test for non-tail recursion and the tail recursion. I am passing 10 as the n. Let me run the unit test first and see the results. Here, both unit tests are passed. Now, let's pass a bigger number to n and see the results. Here, I am passing 50,000 to n and going to run the unit tests again. At this time, both unit tests are failed. Now let's see the reason for the failure. Now if you look at the first one, non-tail recursion calculation, it's failing with a stack overflow exception. If you look at the tail recursion as well, it also failing with the stack overflow exception. What's the reason for that? Every recursive call create a stack frame in the stack. Stack frame holds local variables, arguments, return address, so on. When you pass a bigger number, stack is filled with a lot of stack frames. Then stack will run out of space, causing stack overflow exceptions. If you look at this method, I will grab the logic inside a try catch block, catching the stack overflow exception. In the non-tail recursion method also the same. But still I am getting stack overflow exceptions. What's the reason for that? As Microsoft says, starting with .NET Framework 2, we can't catch stack overflow exception object with a try catch block. So to avoid stack overflow exceptions, we need to use a counter or state condition to terminate the recursive loop. If you look at the example over here, it is using a constant variable to limit the number of recursive calls. Now let's see, when we write the same algorithm using iteration, it means using a loop and passing a large number. Here this is the unit test to test the algorithm written using iteration. So and here I am passing 50,000 to n and see the results which failed when we are using recursions. Here it passed. Okay, now let's compare the space complexity of running the algorithm using recursion and the iteration. Iteration use constant space Whereas recursion use more memory as input size increase because it creates stack frame for every recursive call. There are compilers of some languages which are smart enough to optimize tail call recursions, which is called tail call optimization. For an example, F sharp. But unfortunately, C sharp does not have that capability. Here I have written the same num-sum algorithm using tail recursion and non-tail recursion in F sharp. First, let's look at the IL code of the tail recursion method. This is the beginning of the method and this is the end. This statement instructs to unconditionally transfer the control to this target instruction. What is this target instruction? This is the start of the loop. Right? Now F sharp has optimized this tail call recursion to run like a loop to use a constant space. Now let's look at the IL code of the non-tail recursion method. This is the beginning of the method, and like in C sharp IL code, after the recursion call you can see an add statement. Here I have two test methods to test the tail recursion method and the non-tail recursion method. Here I have run both tests passing 50,000. Now let's look at the results. This tail recursion method passed without any issues, but non-tail recursion method failed with the stack overflow exception. Okay, now let's recap what we learned. Iterations are generally memory efficient than recursions. There are some languages like F sharp optimize the tail recursion methods to use constant stack space, but C sharp does not. Stack overflow exceptions can't be handled in latest.NET using try catch, and use a counter or state condition to terminate the recursive loop. That brings us to the end of the session. I hope you enjoy and learn something. Thank you for watching this. See you in another video.